northeast of the United States and Canada can have some pretty powerful thunderstorms during the summer. And we left for 3 weeks to visit family in Canada, but felt a little bit better about leaving BioTrek in Boston because we put our lightning rod system in. We don't know if this lightning rod works, but we know it's definitely better than doing nothing. And as everyone in the marina likes to let us know, where BioTrek is located right now, a boat last year was hit by lightning. And there's this video of a boat in Boston Harbor being hit by lightning. This is where we're spending our 14-day quarantine in Ontario. So while we're in Canada looking at beavers, ospreys, and other wildlife, Pierre explains what the difference is between putting a lightning rod system in a catamaran and in a monohull.
It's more complicated than the catamarans, as you know, because you don't have a nice keel where you can drive the mast into a big cable into the keel. And in the last monohull, last three monohulls I had, the mast was to the salon all the way down to the keel, which is the strongest way to do it. That's the maxis that I've been racing all had hydraulic jacks also installed on the keel, so that's the best way to do it, of course. It doesn't work on a boat like yours, the Mirage, where the mast was on top of the salon, where you had
on the deck.
On the deck.
So we ran a wire on my Mirage.
Yeah, going from the shrouds, because your shrouds were metal, they were stainless steel, but then it follows the contour of the hull onto the keel, and then there was a bolt that actually killed bolts. So it's not the best, because lightning doesn't like curves. It's contrary to man.
I wasn't there when Mary Luce got hit by lightning. What happened with that boat?
I lost everything. I lost absolutely everything. Lightning doesn't like to turn, so it likes to go straight down. And on the catamarans, you have the mast that goes into nowhere in between the two hulls. Lightning still hits the mast, it goes to the top of the hull, and then it dissipates all over the boat, and then the whole boat radiates, and then you end up having issues with, you basically lose all of the electronics, including, in the case of Mary Luce, I even lost the alternators and the engines. So let's just show you how much of a surge we had. But that was in Florida, which was one of the two lightning capitals of the world. So.
And at the dock.
And at the dock. The alternators was very simple. We just had to bring them to a rebuild shop, and they just put new diodes in it, and they were back to normal. But we did have to change all the electronics. At the time, they were all electronics. So I was very happy to change everything, put brand new electronics on. After that, I did install a lightning protection on Mary Luce before I sold it. If you have good electronics with shielded cables, which is a big plus. And shielding won't help you if the grounding is not good. In case of Mary Luce, it was fairly straightforward. It was an aluminum mast, so I could rely on the mast to conduct the electricity all the way down to the base of the mast, and from there I just had to hook up some form of a system that would continue to take the lightning down into the salt water.
And with the Katana 472, I remember very well, we kept the boat in Fort Lauderdale at a private dock. We arrived by airplane, we approached the boat, I heard the VHF. I'm like, why is the VHF on? And then we came in the boat, we heard the pumps, we heard everything running, and you said, we've been hit by lightning. And what happened was all the switches went on. And we had been gone a couple weeks, and the solar panels kept recharging the batteries. So by the time we came back, more or less, the batteries were pretty dead. That's pretty much it, right? What's your recollection?
Well, as far as the Katana 472, it was a different story to start with, because this was a carbon fiber mast. So I fully intended in having some form of lightning dissipation system. Having a carbon fiber mast meant that some of the masts could heat up if they were struck by lightning and just explode on you. So we elected for having a 4-gauge wire attached to the top of the mast, or a lightning copper rod at the top of the mast, and then going all the way down to the foot of the mast. And since I didn't have to deal with the manufacturer, of course, because it was a used boat, and it was a fixed mast also, I just drove the wire right down into the bilge, which are the cockpit lockers, which are under the mast. And then from there at the bottom, I installed a hatch, a watertight hatch. From where I could, if the boat was at anchor for a long time, or we weren't on the boat, or if we were sailing and we could see that we're about to cross a squall line, we would drop a 4-odd cable, a very beefy cable, in the salt water about 15 feet below the bottom of the boat. and with a lightning dissipator attached to it. And just to backtrack a bit, one of the reasons why Lisa mentioned that everything was turned on, which is a bit of a illogical thing. If you think you've been hit by lightning, you would think that everything has been fried. In that case, Katana decided to go with a distributed DC system. So, like, they're starting to sell more and more boats. You know, it reduces the manufacturing time, it reduces the complexity of the wiring, the weight of the wiring, the cost, and everything else. So it's very smart. The problem with a boat is if you have distributed DC, you have those big DC cables running all over the boat to those junction boxes, and then from there it's distributed to the four corners of the boat, in the engine room in the back, and then the cabins and the center, or the five areas of the boat. And these boards all fried when they got hit by lightning. So it's not that all of the peripheral got hit. Like in that case, because it was a lightning that was within the limits of the system, the VHF kept working, and a whole slew of other electronics kept working. The wind indicator was gone, of course, but the alternator weren't shot. So there were a bunch of things that were saved. The damage was quite minimal, except for these boards that was distributing the DC throughout the boat. They all turned on and were welded on. They smelled burnt if you open the box. And I said, this is ridiculous. I cannot rely on these things. If it happens to me again, that's just like, and the cost. So I ended up once again removing all the wirings to the whole boat and rebuilding all of those so-called distribution boxes, because it does make it makes some sense. So I rebuilt every one of the little boxes inside the boat, removed the board, and put some car relays, the 12-volt car relays that everybody knows about. And then I just reinstalled all of these, and all controlled by the main instrument panel that I had in, with a multi-wire cable that was shielded to the boxes, properly grounded, shielded back to the main panel in the boat, where I could turn on and off everything. Was identical like the way it was before. Once we had done all these modifications on the Katana 472, during the whole around the world, we never had one little itch of the electrical systems. Everything worked perfectly, inverters, batteries, everything else. So it was again, a plus to have done the work.
On BioTrek, we do have a lightning rod system, which is composed of a rod at the top of the mast, a wire that runs down inside the mast to the base of the mast, and then we have a contraption that we can attach at the base of the mast. I should also mention that when we left the boat for 3 weeks, Pierre removed the wind instruments and the VHF from the top of the mast, leaving only the lightning rod exposed. These views of the top of the mast show all the instruments, and the lightning rod is the grayish bar. So this is where the wire comes out at the base of the mast. There's a screw, and then we attach another wire that's not usually there unless we want to put the lightning rod in. And this is Pierre showing how he attaches the lightning rod. So he's going to unscrew that, which attaches the wire that's run through the mast, and he's going to then attach the wire that's going to go into the water. It's really important that these are copper bolts and screws, because if it was stainless, it could potentially just catch fire. So this is the lightning rod now, the part that's going to go in the water, being attached to the wire in the mast. And the reason that we have this system rather than the one we had in our Katana is because this is a rotating mast. And so the wire does not permanently come through the mast, but it's just attached at the base. So now attaching it, and then dropping the wire into the water. We don't leave it in all the time so it doesn't get marine growth. We do remove it and just leave it on deck during good weather. It gets stored away at sea. So that's the end that has some holes in it.
So it's a big piece of copper that is supposed to dissipate the lightning. So it's built with a spike in the middle and with as much surface as possible. And it's supposed to be one of the most efficient ways to dissipate lightning in salt water.
Here it is stored away. Unfortunately, the manufacturer that sold us this doesn't exist anymore.
I think it's around a 4-gauge wire that goes from the top of the mast to the foot of the mast, and that's where it's stopped. Being a rotating mast does create a lot of issues. First, the loading and the fact that it's rotating is an area that has been, designed by computers, and they really don't want to mess with it. They certainly didn't want me to start drilling holes in the area for stress reasons. The wire was delivered to the front of the mast, which meant that because there's a traveler just from the mast, it's not an area where you can put put the wire easily and keep sailing with it, even if the bad weather is bad. The second one is, since we couldn't go to the lockers below the mast easily, the wire at the moment goes from the mast at about a 40-degree angle down into the trampoline and then straight down into the water. So there again, back to the principle that lightning doesn't like to bend. It's not the optimum solution. I might look in the future into finding a way to get it straight down, but at the moment, that's the way the system is rigged on the boat.
It seems a lot of boats get hit when they're either at anchor or when they're at a dock rather than in the middle of the ocean. All the people we know that have been hit have been either in Florida at a dock, in Bahamas at anchor,
Singapore,
or Singapore.
It doesn't happen that often at sea that you really see air to ground lightning. You do see cloud to cloud in quite often, but not that often going down to the water and hitting a boat.
So this last part of the video is when we finally got out of quarantine and were able to visit family. Here's a tour of the lake, Stony Lake in Ontario, just taken with my iPhone, going by Burley Falls, and beautiful cottages on this lake. And there's the church on the rocks, so it's a church located on an island. And the remainder of this video will just be scenes from Stony Lake and some conversations and swapping sailing stories with my family. My father Keith built a lightning sailboat in his backyard, and here he is talking about his accident, an accident that impacted me at my choice of career.
It was like July the 13th, Friday the 13th,
1973.
1973. So rather than take the mast down, I put a ladder up. I thought that the centerboard was down, and the boat went by and made a wake. And it started to go like this, so I jumped.
Yes.
I jumped. I thought I would jump into a white cedar tree, and I missed the tree and splatted on a rock beside the deck. And I was in the water for 2 hours while they brought an ambulance team over to get me out of the water. I had a broken back. I was a paraplegic for 4 days, and they wondered whether I would ever walk again. But I did.
A friend of mine was a captain on Maxi, and it's a 120-foot boat, 130, 440-foot mast. You know, it's pretty big. These are the ones they were using for the Whitbread. And he just got a brand new mainsail. So he said, okay, now we've got to go and mark the sail where the spreader patches are going to be, so that when they're sailing and the boat is rubbing against the spreader downwind, it doesn't chafe too much. So he said, Pierre, are you up to it? I said, of course. So I put my climbing harness on. The captain of the boat, which I knew quite well, Rick, which he met Lisa in Fiji, they had those coffee grinders on the boat. You know, it's these horizontal winches, and you put two guys face to face, and they're all grinding. He said, Pierre, you're ready. Well, first thing I knew, my feet were going up first because it was going up so fast. Problem is, 120 feet up is if you get a small wave like the one you had, then the boat starts to go, and it's the effect is pretty hard at the top end, and you've got to hold on to the mast. So you keep looking around. You're doing whatever you're doing, and you keep looking around. If you see a wave coming, you stop whatever you're doing and just hang onto the mast or tie yourself a rope around the mast, and you say, okay, now let's wait. No waves. You continue working as much as you can. And say, okay, fine, okay, drop me one spreader. It drops you one spreader, and then you start with the pen, drawing on the sail. Where you know the spreader is, so that you know where to put the patch. And then, okay, now no waves, drop me again to the next spreader. Yeah, like 5 spreaders of that thing. But that was at sea. You have to do it to the main up.